And in the last week, we're going to be concentrating back again on transformer models in general. So transformer models have been around since really since 2017. They started out small. They started out more specific. The cool thing about the smaller models, the different types of transformer models, is that you can train them from scratch on data that you have. You can domain adapt them as needed. Things that are actually more difficult to do with these very large general purpose generative AI models. And there's certainly sometimes when you want to use a more custom transformer model that has specific capabilities rather than doing everything with generative AI. But know that it's all underneath the hood. It's all the same. It's all transformers. So they all have that in common, and they all work essentially the same way. We had my second typo in an email that I sent out. So I wanted to check on the schedule for next week and the following week. So for next week, what we'd sent out was that it looked like the days were going to be Tuesday, Wednesday, Friday for next week and for the following week. Well, the last week we have Memorial Day. Yes, it's Memorial Day. Isn't it Memorial Day? Isn't that terrible? It's Memorial Day, yes. So we have Memorial Day. And so we did not want to meet on Memorial Day. So in the final week, we were definitely Tuesday, Wednesday, Friday. Gonna do that. But in the email, it was unclear whether the next week was going to be Tuesday, Wednesday, Friday. And what I'd like to know is, if we were to keep with the Monday, Wednesday schedule, Monday, Wednesday, Friday schedule for next week, is there anybody who cannot make it because you saw the email and you scheduled something during that time? So if you cannot make the Monday instead of the Tuesday for next week, put up a red X. So if you've already scheduled meetings, you can't make that Monday because it looked like it said Tuesday, Wednesday, Friday, put an X, okay? I'll give you a moment to put an X up there. Okay, so we have 3 folks. Okay, then let me go ahead and clear the output. If we keep this Tuesday, Wednesday, Friday, as it appeared in the email, is there anybody who could not make Tuesday? So anybody who scheduled things on Tuesday. Oh, lovely. It's 3 and 3. All right. So what we're going to do, then is we're going to make sure that we have recordings for everything. Since it's almost exactly equal, let me ask you how you read it. How many people thought that next week's schedule was Tuesday, Wednesday, Friday? Put up a green check if you thought it was Tuesday, Wednesday, Friday. That's how you read it. Green check if you read it Tuesday, Wednesday, Friday, because that's essentially what it said. Okay. We're hitting that. Okay. All right, folks, we're going to keep it Tuesday, Wednesday, Friday for next week. So it'll be Tuesday, Wednesday, Friday as it appeared. And for those of you who cannot make that Tuesday, not a problem. We're going to have recordings for it and have that available for you. And you'll also be able to meet us during our office hours for any questions that you have around that. So then let me mention, I was going to add a special extra day to go over the architecture of these models. This is a more in-depth look of the architecture of the models. And what I'd like to do is I'd like to offer that on Monday. So Monday during the regular time is a special session where we're going to be going through the architecture of the models using formal pseudocode. I'll send out an email about this. If you are in the protein dynamics group, you'll need to attend the session or watch the recording of it, because it's going to be especially important for you if you're doing custom models like you do in protein folding, protein dynamics, to understand what the architecture and exactly how these models work. We're not going to be able to go all the way in. If you want to go all the way into this, take my semester-long course, which is open to graduate students and to some undergraduate students. and to postdocs, and I welcome faculty as well, can send you information about this semester-long course, but this will at least get you toward understanding exactly what's going on with these models in the special session on Monday. I'll send an email about this. And we'll also send you a little bit of homework to do before we meet on Monday. All right, so in closing, next week is Tuesday, Wednesday, Friday. The following week is Tuesday, Wednesday, Friday. That's how we're going to close out the session. Next week, we're going to be talking about LangChain. You're going to learn how to build and to greatly expand the capabilities of these large language models. And on the following week, we're going to be concentrating on doing training, supervised fine-tuning. You're going to learn about how these models turn from large language models into these useful chatbots that we have. Any questions about any of this before I hand this over to Professor Bell? All right.
Right, thank you so much for that introduction. Welcome back, people. You made it, day 3 of our coding week, our AI assisted programming week in Python. Very exciting times. I'm excited for you to learn more about LangChain next week, and I'm glad that we've had the opportunity to talk about the foundations of how such a framework is built. Today, we're going to learn a little bit more fundamentals of Python and also just gain some experience in trying to implement some of these models using the APIs. And I'm pretty excited about that. So let's see. Let me go ahead and I think we've sent out the repo, but it should be looking really, really familiar. We're back in the AI Summer repo on GitHub. There we go. Again, we'll be doing a lot of real-time coding together. I hope you choose to participate so we can code together. You can generate your answers. Also, if I start asking questions, like, please feel free to respond. I love the engagement with you yesterday. And let's just keep that going. Very exciting. All right. Hopefully Hugging Face will work with us today, though. All right, let's see. I'm going to go ahead and share my screen. Oh, let's see if we can get the right one this time. There we go. I think that's the right one. Good, good, good. Move things on back. All right, so as normal, here we are back into our repo. This is where we keep all of our code. Again, if you get a little bit behind or just want to look over the solutions, they're right here. And here is our workbook. This time I appended a WB to it. So this is the one that we're going to be in today. Let's click it. And what we can also see is, again, we have this badge, which allows us to open things in Colab. We're going to go ahead and click that because we know that in GitHub, we can look at this all day, but we can't really interact with it. So let's open in Colab. Exciting times. Okay. So you don't need to do this, but I'm going to do this right quick because you know how it starts. Quick quiz. All right. Rapid fire round. Just shout it out. Shout out the answers. All right. Let's see. So we have all seen, or shout out or put them in the chat. Just type really fast. We have all seen how this code before. Should look super familiar. We talked about this the first day when we were talking about Python kernels and how we can read these emails in a structured way. Okay, this right here should look super familiar. Okay, somebody tell me, or everyone, anyone who is interested, tell me, let's see, tell me an example of a dictionary. And you can just call it by its variable name. Tell me an example of a dictionary that's in this code. Nice, people are moving quick. Header dictionary. All right, people, tell me what's good or something about dictionaries. Tell me about their structure. Tell me about how we know that something is a dictionary. Beautiful, they're key value pairs. Perfect, perfect, perfect. In syntax, how do I know that something? Perfect. Oh, you beat me to it, Emily. In the curly braces, just like this. Perfect. All right, now tell me about lists. What do we like about lists? Or where is a list here? Can you give me an example of a list? Ordered, perfect. List are ordered. Email body, yep, there goes a list right there. Perfect, perfect. Y'all are doing great. Ordered, yes. Lines, ooh, interesting. Yes, yes, lines is a list, nice. All right, let's see. What else is good? Let's see. Tell me either a function or a method in here. Any functions, any methods that you see. Beautiful. Process document, great. Split, nice. Working on strings. Append, nice. Strip, those are really good. Perfect, perfect. All right, someone or people, give me an example of, and you might not know this phrase yet in the context of what we're talking about, but show me an example of conditional execution, meaning that if something happens or if something is true, then something else happens. Yes, yes. Beautiful, beautiful. And we see beautiful if-else statements. These are conditional execution. Perfect. It helps us establish some rules by which we can conditionally execute one block of code and not another. Nice, nice, nice. All right, let's see. Can someone tell me or respond an example of iteration? Where do you see iteration here? Nice. For loop, exactly right. So now we have just in this function, as you guys have correctly identified, this process document, what we see is that we have a lot of different data structures. We have dictionaries, we have lists. We are already using some classes and making objects out of them and then using the methods for those objects. We can also see that same sort of thing. So here we see it with the string. Here we see it with the list. We see that we have some iteration here, and all of this is contained within that for loop, which does the iteration. We actually have nested conditional execution. So here we can see an if statement, but it also has a corresponding else. Within this if, we also have an if else. Within this if else, we also have this if. So we see that we can, one, nest this conditional execution. We can nest it in for loops. We can do the reverse. We can put functions in our conditional execution in our for loops, whatever we want. All right, let's see. Last thing, two things. What are the inputs to this function? Thoughts? Beautiful. It is document string is, so this is actually going to be a little bit of a harder question. Is this the name of a variable that we would, is it required that the name of this variable matches the one that we will actually pass into when we use the, great, you guys already beat me to it. Exactly right. So we use this here. It's like a dummy, like representative of the thing that we will be passing in, and then we will reference it as we go along. But if we have something that we're actually going to use, like when we're actually calling the function, that name does not have to match exactly. Perfect. Now tell me about this.
I have a quick question.
Go for it.
Sorry, I was just wondering, do you have to have a dummy variable or can you just leave it blank? Or just like open brackets or parentheses, I mean?
Absolutely. So you can have just like this, like, you know, the parentheses with nothing inside this. But what that means is that you're not passing anything in to this function.
Okay, that makes sense. Thank you.
Okay. Also, though, if you have something called document string like this, and then within here, passing nothing in, you have document string here, that means you're actually working on that's out here. So be careful of that. We really like this encapsulation where we, I don't think that's the right word that you use for programming anyways, but we really like it when everything that is needed for the function is within the function or passed into it or returned. We don't like really variables outside of the function influencing ones that are inside the function unless you directly pass them in. So that's a really, really great question. All right, let's see. Yes, yes. Last line, line 28. Tell me about line 28. What is that? What does that do? Thoughts? Nice. These are the things that come out of the function. Very good. Returns the value of the function to be used in other methods. Nice. Ooh, ooh. And you even said that the types, we turn a tuple and we have a dictionary and a list. Very nice. So these are the things that are returned from this function. And so that allows us to use them further in the kernel if we assign them to something. Really nice. Excellent work. Guys are most professionals at this. Nice. All right. So as you can see today, what we're going to jump into a little bit more is going to be more about conditional execution. We're not going to go into conditional execution like that far. That's okay, but I think it's a little bit of an intuitive concept to us as decision makers. Also, we'll talk about tests, so how we can verify that the code is doing what we want it to be doing. We'll go into iteration just so you are familiar with some of the odd structures that you might see in Python. And then we're going to go into a little bit of practice with the APIs. So I'm very excited about today. Nice questions that have already been asked. I'm super pumped. Okay, so coming back to this example, this thing, we've already said that we've already seen some conditional execution here, right? So we've seen that we have this Boolean where we enter this function. We want to know if something is in the body or not of the email because we start with the header. And we see that this thing starts as false. So once we start iterating through our lines, we have this if, else block. Let's talk about that. So one, we can think of just if statements. So actually I skipped forward a little bit. So for example, we have this straight up if statement. There's no else that goes with this. It just means if this thing is true, then you're going to execute whatever's in the body. And then you're just going to keep on going. So it's just a little track that you go down if the thing is true. And that's the only thing that influences the behavior of this. If it's true, then you do this. And then you just keep going. If it's not true, then you don't do it and you keep going. Okay. So that's if. Then we have this if else. Okay. These are like mutually exclusive decisions and you execute exactly one or the other, right? So if this condition is true, then you do whatever's in there. Otherwise, you do this other thing, right? So maybe I have two things to choose from. Maybe I am trying to decide whether, I don't know, I like the green ball or the red ball more. If I say that I like the green ball, that means that I like the green ball more. And so the red ball just kind of falls away. That one we're not even thinking about. So if this thing is true, we execute this one, and then we forget about the rest of the if statement and then go to the rest of the code execution. If this thing is false, we go to the else. We don't even look at that right there. This can you even see this? I can't see this. Oop. Let me make this bigger. There we go. Oh, not too big. Can't see. All right. So then if this thing is false, then we go on to the else and we run this and then we keep on going. Like this is not even something that we look at. Okay. We can see examples of that here. If this colon is in the line, then we do all of these things. And if lines is in key, then we do these things. But if colon is not in line, we forget about all that. We just go straight to the else and then we execute this. So again, if this colon is in line, then we execute all this. We don't even see that, and we just keep going. So if this else is false, then we go, I mean, it is false because we're not going to this else because we're clearly in this if. So then we just skip on across that and then just go straight to this, okay? So either you execute all of this, or you execute it, or you execute this, and you don't look at the other one. It's truly mutually exclusive. It is also the case that sometimes like you have multiple mutually exclusive decisions. So you can think about like if you're going shopping maybe, and maybe you just go across like you have like some different brands of cereals that you're looking at. For example, you have like, I don't know, the Great Value, the Dollar General, the Kellogg, whatever have you. And imagine that you can only go down this list one time and pick out something. So if you like this one, then you choose that one and then you're done with your if statement. If you don't like the first three and you pick the fourth one, then that's the one you pick and you're done with this if else if statement. So this is just an extended if else if you have multiple conditions. So this allows you to explicitly specify these things. So we've already seen that for our code. I think maybe we're pretty comfortable with that. Yes, thank you, Jesse, for answering that one. That's really interesting. I think that is a good question actually for ChatGPT or GPT-4 that you've asked. Because this one starts off as false, the only thing that can set it to be true is actually this if statement. And then after this if statement sets to being true, it's always true. Nothing can set it all false again. But once you reverse that, it could be the case that, I don't know, it's something to think about. I have to think about that a little bit. But I think ChatGPT or your generative AI can answer that pretty quickly. Maybe so. Maybe header true, and then, set this one to be false, and then that's like it. I think it just, I don't know, maybe, I guess it depends on the way you want to code it. I like that. That's a good question. We can explore that as well if you'd like, but I think your generative AI will have a good answer for that. All right, so moving right along, now we're going to get into tests and asserts. Okay. So this is something that is really interesting, but you also never really see this until later in your coding career. It's like either like, it's pretty much your second class, but this is a big deal for us. Especially because generative AI is going to be generating some code, and we may or may not really, fully understand what it's doing. But what we can do is write some tests that make sure that it is at least semantically correct, because it will probably be syntactically. That's not true. So when it is syntactically correct, meaning that it runs, we want to make sure that it actually does the thing which we want it to do. So tests are going to help you to do that. To make sure that they actually do what you want them to do, and that's what's the most important for us. But two is that they're robust to failure mode. So for example, we have like a bunch of if statements, if else, like this. A lot of tests should have coverage of all the different ways or branches through which you can execute these, because these are great ways to just get into these situations where you haven't actually addressed a weird effect of one of these conditions. So we like tests, okay? Tests, there's a whole unit test, that's like a whole area of like software development. Okay, but we are going to think about this particularly in terms of semantics and making sure that it's doing what we want it to be doing. And so the way that you can approach this is thinking about a set of test cases, okay? So when you run the code, you have in your mind what you want to do. You should make a case that reflects what you want it to do exactly, and then run this through the code, and then make sure that your output of that function matches the thing that you expected. And then you can think of other cases. So maybe if you have an email with this particular format or that particular format, you can make sure that things have the right length and things that are output correctly. So let's just take a look at this, okay? Let's do some examples first, and then of course, you'll go into a breakout room and try it on your own. So we're going to use this process documents function as an example, and we are going to think about some tests that we might do. Okay, let me kind of scroll down. So one, first thing I'm going to think of is basic structure. If I put in a certain input, will I get desired output back? So like in terms of length and structure, like I'm really after the structure, not after the actual content. So let's see, what would that look like in terms of a test? So now I'm formulating in my mind the test case. So I should define then what should happen. So if the input, and this is also important, a lot of times you want to use tests that are sort of like dummy. So you would write the actual input case for this thing, because oftentimes like things that are coming from the data, that they're like the data is so big or so complex that you actually can't look and see if it's right. When you create the case like this, that means you know what it is. And then after you get like the easy cases out of the way, then you go to what's actually in the data. Okay, so what we have written, what we have decided is we're creating this little fake email here, and we're creating our own inputs. Why are there 3 quotes around the text? So try to put one single quote here and then try to write this like this. And you will see some syntax errors. These 3 quotes allow us to spread this across a couple lines. That is such a good question, actually. We're so observant. Okay, so now we have this input email. We have a header as we kind of expect it to look, and then we have a body, right? And so now we can just look at it. Actually, let's execute this. Oh, run anyway. I don't think there's anything about that to execute. Oh, yes, there is. So make sure to execute this one because that's what we'll be using. All right, coming back down. So now we have created our test email. This is like what an email would look like. Now we can call this function. So that is our function. Here's our input, and we expect to get an output. Right, okay, and this is what we get. We get this dictionary, correct? And we get this list, and we get them as elements of a tuple, okay? Oh, actually, now that we have that on, I'm actually gonna remove this. It's gonna distract me. Remove this. I was gonna ask you about particular line numbers, but you guys nailed it. All right, so now let's verify the behavior. All right, how can we do that? Well, there's actually some built-in functionality in Python that's called asserts. And asserts are essentially going to understand, asserts are essentially going to help you understand if something is true, and it's going to throw an error if it's not. So the easiest way to understand this is through an example. Keep in your mind that an assert is actually not a function. So you will not enclose anything in parentheses. That's a great way to run into a situation that you don't understand. So how do we do this? Okay, so in our minds, what are we thinking? We are thinking that one, we expect that we should have like 2 outputs. So like this is one like object, but it should have a length of 2, right? Because this thing here has 2 parts. Then we might think that the first thing that we output should be a dictionary, and the second thing that we output should be a list. So those are going to be our conditions. We're going to check to make sure that 1, this thing has length 2, meaning that it has 2 elements in this return thing, this tuple. And then we're going to make sure that the first element is a dictionary and the second element is a list. So how can we do that? What you're going to see is a little bit of some new functionality, but it's really exciting. So we're going to use this assert statement. And again, it is a statement, so we're not going to be using parentheses. So what we're going to assert is that the length of this processed email thing is 2. And so that double equals means that is checking for equality. Single equals would be assignment, and that's not what we want. So here's the thing that we're checking for. In the case that this fails, we would probably want it to print something and tell us what's wrong with the situation. So we can actually write this, and maybe we want to say, if that thing fails, the len of process email is somehow not equal to 2, then what we should say is the function did not return the correct number. All right, so let's see, let's just run this one straight up. Shift enter. All right, so you didn't see anything output, right? You didn't see anything output? That's because we passed this assert. That means that this thing is true. We're having a good day. Great. Thank you, ChatGPT, GPT-4, Bard, whatever have you. You wrote great code there. 2, what was the other thing? We wanted to assert that that first element in processed email is actually a dictionary. So we're going to use a built-in function called isInstance. And what we want to know is instance. So is this instance? I got an error there. All right, processed. I want to know if processed email at 0 is that. So this element, this first dictionary, is that a dictionary? So isInstance checks to see if this thing is an instance of a dictionary. So is it a dictionary or not? And so this will return some value because it's going to return a Boolean. If it's true, then we're set. We're having a good life. If it's false, we want to say that it is false. And we want to say something about it. And let's say the function did not return the first element as a dictionary. All right, let's run that one. Running both of those. Things are looking great. Very exciting. Lastly, we want to check, actually, that is the thing. So we actually want this thing to return a string, not a list for the body. Because when we have this running over a lot of different emails, we want the final list to be a list of strings. So the body should just be just a big old long string, right? So for each email we read, we don't want this list of things. We want one string that says, "Dear Jane, the cat is out of the bag." Okay, so now what we can do is we can check to see if this element here is a string. Because actually we don't want it to be a list. We want it to be specifically a string. And if it's not a string, then function did not return the second element as a string. All right, so now you see the functionality of this behavior, okay? And so what we see is that this actually is going to throw an assertion error, because these are things that we assert are true. This is used a lot during testing. So now we've asserted these things. And so now we know that this thing is true. So when we run our code, so this is used a lot during testing. But when you run our code and we see that this has failed the test, then we know, okay, well, we need to go and fix something about this function, because look, the second element isn't a string. Okay, so that is what we would know from this. And this is where tests help us, because this code, again, was generated from ChatGPT. And so now we see that what we need to do is ask it a few more questions about how to help it be what we actually want. So here, let's talk about a different kind of semantics, or essentially semantics in general. Another test case that we can think about is if we prepare these inputs, we actually know what the outputs are, right? And so we would expect that the input, or our expected outputs, okay, would match the outputs of this function if it's behaving correctly. And so that's what we'll do. So here's our test case. All right, so we have the same input email, excellent. And now since we already know what the correct output should be, then we're just gonna make that. So here we have exactly what we believe the output should be. So here is the case what the header should be from this. And here is what we believe the body should be from this. So let's run those. And now we can just process this email as expected. So just run this like normal. All right, and now what we want to make sure of is that this thing that we got out exactly matches what this thing, okay? So this, what we expected, is exactly this output. So let's see, we already have this intuition that this is going to match, right? Because it's looking pretty good. But we already also have a feeling that this is not going to match, because what we wanted, again, was a string coming out of this, not a list. So we have some expectations there. So one, as we said before, this thing right here is a tuple, right? Because we return 2 elements. It's a tuple of 2 elements. We can like split that into pieces. And so the way that we do that is we take this process email and we just like assign it to 2 separate variables. So that's what we'll have there. Now let's write that assert. All right, so what is it that we're trying to write? We want to assert that this thing here is exactly the same as this thing here, because this is what we expect to get out. And we also want to assert that this thing here is the same thing as this thing here, because that is exactly what we want. Okay, so let's see how we can do that. Just more assert statements. So let's see, what can we assert? Exactly what we just said. So we want to assert that this processed out header is equal to processed out header. That's the thing that came out of here, is equal to what? What we define and we want to be true. True out header. And then if it's not true, that's the header of the function. Oh, output is in. All right, and so something else that we would know is the same for the body, so we can go ahead and write that. True out body, we would say the body of the function, but it's not. Or, sorry. We'll write that. All right, and so one, we feel really good, part of this, because here, we see that, this is correct. This one is not so correct. Let me look where. Chat, okay, so, asserts are really, okay, so one, we are talking about testing a little bit. And there is a whole framework of testing. Like, it's not just like, oh, I just write this test. Like, there's like methodology and there's like a lot involved with it, specifically when you're talking about code functionality. And so this is a way that we can do this for semantics more easily. But there's just like a whole entire framework around this. For example, if you were going to really do like unit testing, you would use like the unit test, like, module of Python, which organizes this in such a way that you can always run tests. So what I'm trying to say here is, let's say that we change this function. We would actually, let's say that we change this function in this notebook. It would actually be better if all of the asserts were in a function that could be applied to it. So essentially, like this, the way we have this written is not the best way to write it from like a software engineering standpoint, but this is getting the job done for us to the extent that we need to do it, to check, to make sure that like the semantics are what we want. Because again, our generative AI would be generating most of this. And so we just want to make sure that it's doing what we think it's doing. So that's what we're really about. We like asserts. So the thing about asserts is so I don't know if this is true about Python, to be honest. It's something I need to look up. But in other languages, you have asserts. You will always have asserts in your code, and you can always just have the asserts in there to make sure that things are working the way you want them to be working. And so when you run this in a debug setting, the asserts run. When you change it over to a like production, the asserts they sort of disappear and they're not. So then you don't actually have to change your code, but you always have the asserts in there if you want to go back to debugging. The thing about if statements is that they will always run, period. So now you have this, like, we've already written 1, 2, 3, 4, 5. So we've already written 5 of the, we already have 5 of these written. Like if this is 5 if statements, that would always run no matter what, it will slow down our code. Asserts usually going to snatch it. Also, your if statements. I'm going to look at those just right quick. Yes. So actually that's, yeah, that's true. So essentially also when you're testing, you might want it to stop running so you can see where it's wrong. Also, when you run things, so this is getting to be a little too much, but when you run things in debug mode, a lot of times you can set the, like it will break in a function. And so you can see the values of the function where it is broken. And so you can kind of see what's going on within it. So it can be like really nice. Those are great questions. I wasn't expecting that. It's a great question. You're great at this. I love your intuition for asking questions. It's fantastic. All right, so let's see. So we just talked about basic code structure, making things the right, making sure things are the right length and have the right type. Then we talked about semantics, that you have some input that you like, and you want to make sure that the output that you expect is the output that the function outputs. So then a lot of software development is going to be around robustness, right? So we're talking about the different paths, the mechanisms of failure. For our purposes, like again, if you get to that state, you want to look into the methodology around that and use the appropriate packages, because there's like many of them that do this extensively. But let's see, maybe what we want to check in terms of robustness is that we have just some email that has no body and it only has a header. Like maybe, I don't know, whatever processed it messed up that particular one or what have you. So we can write a test case that's like that. And we can just kind of check to see if it works under this condition. All right, so it runs and that's exciting. But the question is, what did it produce? And so what would we expect for this to produce, right? We would expect for it to output, hey, you can answer this on your own. Think about what you expect it to output. What we would expect this thing to actually output is just this dictionary and then an empty list. So yes, beautiful, oh, so good. So we have this tuple whose first element is this dictionary, and the second element is not like nothing. It is an empty list because there's no elements in it, but it's still a list. So now let's verify that then. Let's write asserts for that. So we're going to assert that out header exists. So there's some different asserts that we could write for this. We could just say that it exists and like it is not empty, right? Because we could have just like skipped over this whole thing because it didn't have a body. So we want it to be non-empty, and we can just do that by saying assert that this thing, this variable name, and that checks to make sure that it's non-empty. And then if it is empty, we can say the header is not empty, or email, which has a header regardless. Now about this body. We want to assert that it is empty, should be empty. So the way that we can do that, okay, so if we were to write out body, we would assert that it is not empty. So there's stuff in it. But we want to assert that it is empty. So we're just going to reverse that. We're going to do not. So this means that we're checking to see that out body, that variable, is empty. And it should be. So let's see, the list should be empty or an email with no body. Great, we got exactly what we expected. Okay, we can be excited about that. If we want to see that with our eyeballs, you can see out header there. And we can see out body there, empty list. Someone is asking why we say, don't say out body equals like empty set, empty like set, or empty string, or empty list. Some things are Pythonic. And so there's like there's like a whole like theory and methodology and a mentality around Python. And so this is the Pythonic way of writing this. Okay, all right, so now breakout room time, exciting times. And so what you're going to do in this breakout room is you're going to think through some test cases on your own. You're going to write some of your own, okay? So one, you're going to write a test case so that you make sure that the things that we see in the emails it actually works on the things that we see. So for example, you actually might have to pull up, I put the solutions here. So you can use this if you want to. All the solutions are down here. Can't retype all of this, but this right here is what the header looks like. And so that looks a little bit different than what we've done before, because it has like all these crazy blah, 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 and then it got exclamation points, like you never know. Maybe the colons could be off, whatever have you. So you want to make sure that it actually runs on this in the way that you expect. Then also make sure that and this is also a design decision. So we're writing a test that ensures that the code runs with no header and only a message body, but that there is a design decision. Like it could be that you actually don't want it to run like that. But in this case, we're going to assume that we do want the code to run that way. And so you're going to write a test that makes sure it runs, even if you have no header. So you should return this empty dictionary. Ooh, nope, can't tell you. You're supposed to do that. All right. So then think of another test that you can use to test the robustness. You can also ask your generative AI to help you make tests. And then if you can, fix the code where the asserts fail. And so that could be a little bit of a something that's interesting when you look at these asserts is they really kind of check for one thing, but not many things. And so you have to write like mini asserts. It's interesting, and it'll be interesting in this context. All right, let's do 10 minutes. get out those breakout rooms.
I can go ahead and open them.
That sounds great. Let's do 10 minutes.
All right, they are open.
Thank you so much. Does anyone need help getting into their breakout room?
Hi, Shiro. It's Lynn Cooper.
Hey.
I turned it down because I have to step away, so I'm not going to just lurk in the thing.
Okay.
But separately, I am working on a paper where I would like to use a whole bunch of run a very large a number of series of ChatGPT sessions with different types of personas, and then do an analysis on what's part of the persona. So I'm much more interested in actually using the ChatGPT than the coding part at this time. So I think what I'm going to do is I'm going to lurk so that I'm hearing all this in the background. And then after I get the paper written, I'm going to go back and actually learn how to do the programming because, but oh my God, I cannot believe how well organized and how wonderful a teacher you both are. Sure, my husband's with me and he's like, I would take a class from her anytime.
Oh my God, that is so sweet. Thank you so much. I so appreciate that.
Yeah.
It's so true.
It's like we're reactivating coding neurons because he coded his entire career, and for me it's been 30 years since I've done coding. So but it's like riding a bike. So the question I have for you is I'm hopefully going to have a draft of this done up within the next couple weeks. Would I be able to send a copy to you guys just to get your okay, because yeah, Jesse, you're muted.
Yeah, please do. Would love to see that. Yeah.
We good.
Yeah. So is there anywhere you can point me? I mean, I could probably ask ChatGPT this, but any place that you would recommend as a high quality source for talking about detecting bias using personas? Or differently.
So, political science researchers really sort of jumped on this for investigating viewpoints of groups. And that's the only, that's the main place where I'm seeing this right now. And Cassie, let me reach out to Cassie to see what new papers have been there. So Cassie is on our faculty. She's computer science. I'm sorry, she's political science, but she teaches with us. But the problem is that, it's so new that many of them are not published yet. So you can find them in archive, but they won't have been published yet, and except for maybe brief, fast communications.
Yeah, I went to bed last night thinking about this paper. I woke up this morning thinking about this paper, so it's got to get written. But I had talked to Jesse about it, and I have a model for miscommunication for interpersonal communication that I use to teach my students. And it incorporates things like where error correction happens and how different layers of communication gets encoded. And what kind of kept me up all last night was if we are building these large models, large
Mhm.
language models based on what's out there, then are we also, just by nature of the communication that we do, encoding some of the types of miscommunication errors
Mhm.
that, are we encoding Freudian
Right.
slips?
Yeah.
And things like that. So
Yeah.
it's been, oh gosh, I'm sorry, I didn't even have my video on. Sorry. All right. Yeah, so I'm just having a blast thinking
Mhm.
about these kind of things and
And Lynn, to put out there too, just for you to think about, so like next week when we're talking about the when we're talking about LangChain,
Yeah, I was about to jump in here.
yeah,
Go
what you're
ahead,
just
yeah.
talking about could be modeled, first of all, could be modeled using LangChain, where you literally send communication from one to the other, or could be used as mitigation, in those situations as well. But you could model the process like by writing as LangChain, which would be cool. Miranda, what were you thinking?
Yeah, I was also thinking with comparing a bunch of different personas and results from those personas. With LangChain, you can really automate sending
Yeah.
chats to ChatGPT. So you could construct, the different personas that you want, save those personas, and then using LangChain, apply those across a variety of inputs and then get all of those outputs as your data. And so I really think that would be a great way to just, instead of you just going to ChatGPT and doing it all manually, you could really just get a lot of it done in LangChain.
Yeah.
I think next week is going to be very, very important then.
Yeah.
Yeah.
And then
I'm having, oh, go ahead.
Oh, no, I was just going to put out there, and even the assessment of those for bias could be
Yeah.
another model, and you don't know if it's truth, right? But you do know if you're looking for differences from this persona, how the evaluation changed between this persona and this persona, then you can have a separate large language assessment, right, of the bias, and you could say, oh, it changed from here to here, and the only thing changed was the persona. For that, we can talk to you about that too. You'd want to use a large language model rather than a chat bot and have the temperature turn to 0. So it's like repeatable, but that's very cool. I can't wait to read your paper. Hurry up and write it, please.
Yeah.
Yeah, well, I'm playing around with what prompt to give that is likely to elicit. And I'm calling it bias, but I don't think that's necessarily the right term. It's more because that implies negative. Because we're all biased by, what neural pathways formed in that. So just being able to form a reasonable model of how a model of a person is formed. Because like right now I started with person to person. I'm looking at person and AI, but at some point our AI is going to be talking to AI.
Oh.
And then what type of things do they need to understand about each other?
See,
So
that's what LangChain is. LangChain is
Yeah.
models talking to models. So I mean, you're like right. This is extremely timely.
cool. I think
Oh, sorry, go ahead.
go ahead, please.
I was just gonna say, so Cassie and Josh sent me this paper that they did. So the one that Jesse is talking about, they
Right.
are on our the archive. But I had always thought about coding as being like unbiased, right? So they were talking about, oh my gosh, like the bias in the essays and blah 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 blah. And I was like, oh, we don't have to worry about that because of coding. And so now I saw TikTok, and I'm not going to repeat what it said because it might be fake news, but it was really interesting to think about in the context of probably a lot of the body of coding that these models were trained on were made by like certain, like there's a majority population that did the coding. I wonder like how that will affect the code that is produced. Like, is there a different like approach to coding that people take? Like, I don't know, but I just thought it was really interesting because I was just thinking that maybe even if the generative AI is going to generate some code, maybe it makes more sense to the people whose code it was built off of, but other people might not understand it because it's not very well representative of the code that they would write.
Yeah.
Yeah,
Well, my husband Brian and I have had lots of discussions about old style coding, which he and I learned with like the Fortran, the Pascal, the Lisp,
Mhm.
and then early days of C, versus the current generation of computer software folks where everything is in the cloud. And there's basically unlimited resources where we had to manage our memory. We had to worry about execution speeds. And, there were just very different
Mhm.
personalities involved in the code that you wrote. Because I don't think we're necessarily teaching parsimoniousness the way that it was taught, ages ago. Okay, sorry, I hijacked your thing, but thank you so much for the info.
Yeah, thank you. That was, I mean, that's really interesting. I'm excited to read that. All righty, folks, welcome back. Welcome back. I think some people are maybe still coming out of breakout rooms. Let's see. Oh yeah, we're still counting down a little bit. All right. In the meantime, thumbs up if you were able to get all the way through question 3. Thumbs up, made it through 3. Oh, and none of the participants came. All right, so we're thinking about some tests, yeah. And right now we're voting on, not voting, but we're responding to if you were you able to make it through question 3? Even if you didn't make it to question 4, you made it to question 3. Thumbs up, thumbs up. And in the reactions, if you wouldn't mind. Oh no, thumbs down. That's okay. All right. Interesting. Interesting. Okay, gotcha. All right, well, let's talk about it then. So how did the test sort of go? Let me see. Tell me about how things went in the chat. Drop a test, or if you ran into some issues, just unmute and let's talk about it. Let's work it out.
Well, I can go since we weren't able to really fix all the errors. We got the first test working. But when it came to the second one, we weren't able to we weren't able to I'm sorry, I lost where I was in the collab sheet.
Get out.
Yeah, so we put in our input email to without a colon. So it said that header lines without a colon are considered part of the last field. And we were getting like the local variable key reference before assignment error.
Yes, that's really interesting. Extremely interesting. Do you think that that is right? Do you think that that's like a correct error when you look at the code? What did ChatGPT say? Or your generative AI? Did you have a chance to look at that? Anyone else run into the same issue? Thoughts? This must have been a 1. Okay, let's go through the solutions and just talk about it a little bit more. Let me see. Let me share my screen and see if I can be successful again. See if I can get the 2 out of 2. Share. Yes. All right, great. Let's talk about it. All right, so let's see. So a test that ensures that the code can run on the standard header. So here goes the standard header. We'll just go through this one quickly. We truly want this answer, and we truly want this answer. So then this is going to be looking really familiar. We want to actually get some output. So maybe standard header, standard body, and this is what we're going to be getting out of access document. What are we passing in? Standard header email. All right, and we separated those two things. Let's see, we're gonna assert. We're gonna assert. We want, actually, it's about the same assert as what we had before. Assert that true standard header is gonna be standard header. So what we got out, and otherwise, headers do not match. We're gonna do the same thing for the body. And then, all right, we expected this because we have this thing here, which is a string, and what we have as output is a list. And so again, this is where you kind of want to functionalize your tests, depending on like the rigor of what you're trying to do. This is where it's nice to have them functionalized, because normally once we saw this, we were like, oh my God, yeah, that is a list and it's not a string. We would immediately iterate, make it into a string, and then keep going through the rest of the test. But that's neither here nor there. Let's look at number 2, the point of consternation. Let's see. All right, so now we have no header, but we have this body. And let's see, let's give that a try. Maybe we would write, all right, no header, header. We're gonna call that one no header body, process, document, and then no header email, because this is the one that we're passing in. Let's give that a try. What should we assert? We want that dictionary to be empty. So we have what we had before. And if it is not empty, the header should be empty. And then we just want to assert that the body is here. All right, and this would catch the case where you might have swapped things. All right, let's take a look at that one. We didn't even make it to the assert part. That is really rough. So now we get, okay. Now we get this error that says unbound local error. Interesting, that's interesting phrasing. Local variable key reference before assignment. It sounds like what it's trying to say is we have this function and we are like, we have never assigned anything to this value key, to this variable key, but we're trying to use it first. So now let's see whether we agree. Let's see. So this thing doesn't have a body, or no, it doesn't have a header, okay? No header. So we're gonna come in here, split, blah, 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 body flag, false. For line and lines. So if this thing, not body flag, okay, that's where we're going into, right? And then if colon in line, it's not, so that's not in the line, okay. So then we go to this else statement, we just forget about all that. We go to this else statement and we have header dict, okay. Define that one there at key. I mean, what is it? What is that value? And then it's like a key to a dictionary too. So what is that value? Nobody knows, okay? This is one of the points of consternation sometimes with keys. And these are great moments to catch with tests as well. So that didn't actually catch it with the test. That caught it in the process of doing a robustness check with the test, right? Because actually, if you come in here and you go into this not body flag, which would be correct, and then you don't have the colon because there is no header, you would go straight to this else, which we are doing. And now we trying to set a value or set a key in a dictionary, but we don't even know what this variable should be. Should it be organization, to, from? We don't know. That one requires a rewrite. That's just a full rewrite, but because that's just an error. All right, let's see. Where are we? Ah, there we go. So we have problems here. So this is another time where we would trigger a rewrite if we expected the code to be able to run like this. Now, if we don't, and we expect that we should always have a header, period, then we'll just let that one exception out. But it would be better to do it in a way that is not using this error as the way to get to it. It's neither here nor there. But this could also be an exception. But anyways, so what we see here in the process of writing our test, test, our robustness test, is that not so robust. All right, let's see. For question number 3, maybe we want to check that none of the keys or values of the header have white space. The answer for this one is actually like an answer for this one is like kind of long. And so this is just another robustness test. So essentially it could be that maybe we like strip the keys or the values because they're strings, they can have white space on either side. Maybe we kind of failed in doing that. Maybe we never wrote that code. And so we would maybe want to check that because it'd be super weird to match a key with white space. Interesting. And so we can do that. And I will look at the solutions for that one. It's really long, but it is a list comprehension. And basically it just checks to see if the strict variable is the same as the non-strict variable. And so if when they don't match, that means you have white space. All right, let's see. So then, okay, so GPT-4 helped us out with this one. Thanks thing. And so here is where we are helped in the scenario with that key situation, right? And so what it did is if this thing exists, so this thing is none when you start, right? It's none. So we run this one, we run this one. In the case of no header, we check this, nope, because there's no colon, and then we go straight to the else, in which case we go to straight. We check to see if there's a last key, and this one started off as none. So we forget that one, and we come to this one. Now we set body flag to true, meaning that we're about to go into the body, and then we append whatever line this says. Now there still is a tripping up moment, but we can kind of, I don't know, it depends how much of this coding that you want to write. If you expect that most of your documents will fit a certain criteria, like you can avoid getting overly inundated with all of the small little fixes and error checking, because it's not going to be used that way unless you're making a piece of software like for distribution and for people to use. Like if this is something more researchy and you expect for it to be used in a standard sort of way, maybe the standard kind of checks are fine. All right, so let's see, let's run that one. We can also, once we've written this, we can also do some of the original checks. So let's run this one. Yes, I'm up there. Let's run this one. This is making sure that we got the right number of elements and we got the actual thing that we wanted out. So now we're back to having a string. We can see that here. So it's still outputting the same. It's like this else statement is still outputting a list. But when we return the value, we still return the dictionary, but now we're doing this functionality, which is essentially, this is an empty sort of string and we're joining it, using it. Anyways, this is creating a string out of a list separated by these elements. So nothing is separating. Okay, so now what we have here is a string return, and that's how we got to this one. Let's see, let's run that last test that we had. And so this is the one where we couldn't even like get to the point where we ran a search because we were erroring out on the key. We run that and we see that it's working. So now we can feel better that the code does exactly what we want it to do, and it's more robust than it was. But again, there's a limit on how robust you just want to make it. Sometimes you can really just get into the quagmire of trying to make things like super robust in situations that you actually never encounter. All right, let me see. Interesting. So I like that question about using a transformer to generate text. The function may return different responses each time. Are there any recommendations on how to test this function so that the transformer results are reasonable? So that is a good, that is almost like it depends what you mean by reasonable. And that is, I mean, even that requires like a definition, but what you could check is that it is a string and it has some sort of length and that it is not empty. And so you know that it's outputting like a string. You could make sure that it's like alphabet, maybe capitalized, not capitalized, maybe that there's some words in it. But you could also use another transformer to help you with that check, but that would be sort of an extensive sort of check. But people have tests that are just kind of robust, or not robust, but kind of big, honestly. But that's an interesting question. All right, before we jump into iteration, let's take a 5-minute break. And so we will come back at 10:17 to get into iteration. How does that sound good? All right, awesome. I'll see you at, actually, I'll see you at 10:18. 10:18. All right, folks, welcome back, welcome back. Welcome back. We are going to jump right on back in, and we are going to start talking about iteration a little bit more, mostly so we can talk about list comprehensions, which is a structure that you will probably see at great length, particularly in documentation examples. Maybe they've stopped using those, probably haven't, but we see them a lot. All right, let me go ahead and share my screen. Yep, there we go. All right, so here we are in iteration. Okay, so we've already seen some iteration, right? We've already seen that for loop that we used to go over all the lines once we created, once we split on that new line at the beginning, right? So we've seen some for loops. There's a different kind of way to re-express for loops, which is called a comprehension. And there are different kinds of comprehensions. You can make a list comprehension, which is what we're about to see. There's also dictionary comprehensions. And so you make like dictionaries in terms of key value pairs. And then we can also have this generator function, which kind of serves up our values, and we call it. Okay, so we will not see at length in Hugging Face this map function today, but map is a reason why I really like, especially I think it's called PMAP. It's the reason that I really love list. Anyways, it's neither here nor there. So we're going to see all of this today, minus this map function. All right, so let's run on back to for loops. So we have already seen for loops. And so something that we know from what we've seen is that we have this for blank in our list, our dictionary, what have you. And we know that this is just some dummy name. We have for, we have the in, and we have this colon, and then we indent everything that we want the for loop to do. So if this is 10 lines of for loop, then we'll have 10 lines. Then the next lines will be unindented, so we can stop. That will not be included in the for loop. So let's see. So what we have done is we have written the code actually to read and process one email. What we want is to go through all of the emails that we had in that folder and process all of them and store all the headers as a list of headers and all the bodies as a list of bodies. Okay, right? Okay, that's what we wanted. So now let's see how we can do that. So I'm going to share this function with you called glob. There are other ways to achieve the thing that we're about to see, but glob is really great whenever you want to read all the files from a particular directory. So we're just going to run this, import it, bring it on in for us to be able to use. And then we're going to run this line and this line with our exclamation points. Can someone remind me of that exclamation point? What does that do when I'm using it? We don't really see that exclamation point too much. What's the exclamation point doing?
It runs something at the command line.
Ah, beautiful. All right, so we're going to run both of these. It's going to curl down some data for us. We're going to take a look at it. There it goes. It stored it as this name right here. Wonderful. Curling it down. Great. Keep this in mind, like whenever you need to, if you have something, some data that you have in the zip format and you want to process it on Google Colab, you can curl it down like this. And then you can also unzip it like this. So we'll run that one. Excellent. And so now to refresh this one. And so what I went to is this thing over here, refresh it. And we have 20 news groups. Again, that's our emails, standard data set. And then here are our directories that group together different types of emails. And if we look in any particular directory, we see in a second, all of the different emails that are in that directory. And each of these will be an email. All right, great. So now let's finish this up. So what we're trying to do is we're trying to read all of the emails, like file paths first. So we're trying to understand the file paths. So once we get all the file paths, we can load all of the emails and then do the processing on the emails. Okay, so first we got to get the file paths. And again, what we're going to use is glob. Again, you don't have to do it this way. You can always use like, what is it? Lister or something like that from OS. We're not going to do it that way. So here what we're going to do is we're going to create a list. So we're going to call that email paths list. And we're going to use glob in order to do this matching of our file names and return everything that matches this pattern. Okay, so what does that mean? The directory that we had was called 20 news groups. And maybe we want to read everything from sci.med. And then if we're trying to match, okay, we're trying to match things, we're trying to match the file names, then we pretty much want to use a wildcard, which means, all right, anything, like anything goes, everything in this directory, just read it all, okay? So then after that, we're going to read it, right? And then we're going to print the length of that list, just so we don't have to see all of those emails. And we're just going to print like a few of them to start off with. So we're going to print literally 10, okay? Because it could be a lot to look at. And I do this a lot in terms of understanding what I've read. A lot of times, like the data is so big that you can't just look at all of it and verify, but you can look at some of it. And so that is what we'll do here. Let's run that one. All right, so we see that we have this thing has 1,000 emails in it. And here are the first 10 that are in this list. I think there is something about Glob where it might not return things in like a sorted sort of order. And you can kind of see that here. This is 580, and this is, all right, let's see. Now 580, and this is 581, and this one comes first. So you might need to sort that first if you need them to be in an order. But if it doesn't matter, then it doesn't matter. All right, let's see. So now we've got all of these emails, or file pass-through emails. And what we need to do is iterate through all of those emails, read them, process them, store the body and the header in separate lists. All right, okay. Let's start with the first thing. So we got to read these things. So what we are going to do is that we're not going to be reading all 1,000. What do you say, 1,000? No, I'm not going to be reading 1,000 emails. Let's just set a maximum number that we're going to read, and we're going to set that to be 20. And so you can do more or less if you want to, but I'm not going through all those emails. All right, let's see. So then we need to, as we saw before, we would want to set up some variables to hold the list. What do we say? We want to have all the headers. We wanted all the email, or all the bodies. I'm just going to call it all bodies like that. And then we wanted all of the emails. We can actually do without all emails because all we really want is all the headers, all the bodies. But we'll keep all emails because it's something that's helpful for us. All right, so we set that up. And now what we want is to first read all of those 20 emails based on those file paths, okay? But we know our file paths are in a list, so it's this for loop moment, right? So for, maybe we call it the dummy variable email path in, what was it called? Email paths list, email paths list. And we're gonna go up to max emails. So this right here, this just means we're gonna take the first 20 elements. So from 0 to 20 of email paths list. And so not the whole 1,000, colon, let's see, what are we trying to do? We're trying to open, so we have our context manager, with open email path, let's read, we call that thing F, and we're gonna do this email equals F dot read. And so this is actually what we had before, just with different variable names. Then what we'll do is we will, so this is going to read one email. So now we're going to add that email to the email list. So all emails dot append this email. Great. All right, so now we have that email. Now we need to process that particular email. So process that email. What we can do is email header, email body as we expect. Process document this email. Great. And then exactly what we expect. We want to add this onto the list. Add header and body to appropriate list. So what we'll have is all headers, append email header, all bodies, append email body. All right. And it says, can you get an Excel file in a tar format to curl? If your Excel file is accessible as in like GitHub or something like that, you can read it using pandas, because pandas will take a like a URL. You can use the read Excel function. But it does help if you make it a CSV first if you need to, but sometimes you don't want to do that conversion. All right, let's see. So let's run this one. All right, things are looking good, maybe. So sometimes what we want to do is look at, we want to look at some things. So here we're going to look at these all emails, and then we're going to look at one of the headers and one of the bodies to make sure that they correspond correctly. So let's take a look. All right, this lines 11, this should be the whole email. Good. This should be just the header. Does it match this one? Yes, yes. And then this one should be the body. Let's see, and that is the body. So this is looking really good. We can look at more of these, and sometimes I just like take a few, randomly sample, and just make sure that they're okay. And that helps me feel better that I've done the right thing. Also, you can write tests. So let's see, now that we've verified that, we have our for loop, like we've just, actually, we did it. Like that's it. It's already done. So we have read in all those emails, all 20, and we've literally processed every single one of them. So, or not, okay, 20. We processed 20 of them. Okay, so this is how we did it. Not so bad. So essentially we iterated over every single email and did everything with every single email. Is it feeling good? All right. All right, then, well, then let us then transition to how we can write this in sort of a different kind of way that you might see written in that kind of way, just so you'll know what you're looking at. And that thing is called a list comprehension, okay? So you saw what we had just like a second ago, right? Where we had this 4 element in some collection in our colons. We would do some function of the element maybe, and then we would add that element onto our list. Okay, somehow we're going to add the element onto the list. But you saw kind of how that structure of the code was, and that we usually created these empty lists first, and then we appended onto them. Interesting approach, totally fine. That's just how it's set up usually. Let's see, but we also have another way that we can approach this. So these same types of things, right, we can kind of restructure them. And so what we'll do instead is we'll use these big old brackets. What are these brackets for? This is called a list comprehension. So this thing indicates that we're going to have like a list. So we always want to have those brackets. If you don't have brackets, you'll have weird errors, although all this thing is correct. Very upsetting. But so make sure you include your brackets in your list comprehension. And what we do is we just kind of restructure these elements. So essentially we put this for thing at the end. So for whatever element that we're going to iterate over, and then we say what we're going to do with it at the beginning. And then what happens with that is that it completely returns a completely new list. So there's no initializing beforehand. You do everything that you're trying to do in the list comprehension, and it returns a completely new list. All right, so that's really interesting. So this is this is the main kind of list comprehension. There are other things that you can do with it. For example, you can choose which elements that you want to return. And so like for element collection, if, I don't know, element is 7, and then you can apply that function, you've done a filtering. Or you can filter on the front end, like maybe you want to apply like a different function on in the front. So like maybe if it's, I don't know, string do this, if it's a variable, do, I don't know, whatever the case is, you can do different things on the front end too. So let's see this. Let's see how we convert this thing to a list comprehension. Okay, so we're not going to do the whole thing. Y'all are going to do that in your breakout room, but we're going to do a part of it. And what part of it are we going to do? We are going to, we're going to do, let's see, this part. So we're going to use the all emails list that we already have, and we're going to write this as a list comprehension, this whole statement here. Okay, so let's see how we can do that. Actually, it's going to be this whole statement here. Okay, let's see how we can do it. All right, so we're starting with all emails. Our list comprehension is going to be applying process document to each individual email in this list. And we need to get out of it like a list of these two individually. Let's see. So one, recall that we have all emails like this. Do make sure that you run it so you can make sure that, you know, there's data in it. Otherwise, you may need to roll back and like execute the line where you created all emails again. And then let's see, how will we choose to write this as a list comprehension? Well, what do we say? We said list comprehension, so list. Okay, so we're gonna have some kind of list. And then we said we're gonna have the same, if we're thinking about our for loop, we have like, so maybe for, what do we do? This email, was it? In, so for this email in, what was it? We're using all emails, that's it. Actually, we're gonna call this, let's call this email in all emails. And just for the sake of like doing it kind of quick and being able to look at the answers, we're gonna just do all emails like the two. So we're just gonna take the first two. So this is our like for, regular for that we've already written. Okay, so for that, and then what do we need to do with it? We need to process document, right? And what do we need to process? Our dummy variable name that's going to represent our email. All right, so we have the same for thing going on, and we have the same process document thing going on, still using this dummy variable name. And now the last thing to do for us, equals, is to assign all of this to a variable. All right, so let's see, let's run that. So maybe it would be helpful to look at this. So we're just gonna print this out right quick, but shift enter, but it's a little bit, oh yeah, we just did two, and that's exactly why we did two. All right, so let's look at it. Okay, so remember the point of consternation here a little bit is that processed emails, it will be a list of tuples, right? Because it's just a list of the output of processed document, which has two elements, right? So let's see if I can get the first one. Looks like this is the first one. That's the first tuple. You can see here the dictionary. You can see here the string. And then here goes the second one. You can see here the dictionary and here the string. So we're like 90% of the way there. The question just becomes, how can we get like the header and the body separately? Very confusing. We essentially need to take all of the index 0 out and all of the index 1 out. The way that we can do that is through this, not trick, but it's like built-in functionality called zip. And so what we're going to do, so we're going to get all headers and all bodies. We're going to use this zip functionality. And what we're going to do is pass in all the elements of the list like separately so that zip can reorganize them. And the way that we're going to do that is we're going to use the star. I would tend to think about star as like if you have a bunch of elements, like taking them out of their container, putting them into a purse and like getting them out. And so let's see what that looks like. Processed emails. All right, and so let's look at all headers and all bodies. Here we can see that actually that thing is a tuple, but list like, so this thing right here has two elements. First element is here. It's a dictionary, just like we wanted. So now we have all, so we're looking at all headers. We wanted a list of dictionaries, right? It's the second emails header. So now we have exactly what we wanted here. We also have what we wanted here. Here's our list like. So this is going to be a tuple. We can convert it to a list though. Here is our first element of, what is it called? All bodies. Here is our second element of all bodies. So we've essentially got what we wanted to. If we were to iterate over all headers, we would do 0, like this would be the 0th element, this would be the first. If we were to iterate over all bodies, this would be the 0th element, and this would be the first. We could actually iterate over them together to reproduce the original email as well. All right, now it's your turn. Now it's your turn to write a list comprehension. Okay, so we're gonna kind of work this in pieces. Something interesting to observe though, before we even get in there, is that you see that this thing is a function. It can kind of be any kind of function. It's a function that does something on something. This is some kind of operation. And then this thing right here is the for loop. Just remember that. So coming back here, the first thing that we're going to do, our goal is to re-express that code that we just wrote, okay, in the for loop for reading in all the emails and processing all of them and getting them all on the list. We're going to re-express that as a set of list comprehensions, okay? And so first thing you're going to do is write a function is going to read a single file, email and given a file path. So you're going to pass in a file path. You're going to read that and it's going to return the email. You're going to create a list comprehension. And again, I'm just going to say do 20 so it doesn't take like a long time. And it's going to read all, it's going to use this read docs to read all 20 of the emails. And then recall that you can use email paths list, and this can be your collection that you use for the for loop. Then you're going to use what we wrote above in order to actually do the processing. And then you're going to put it all together and make it run. Just make sure it runs. And so as you're going through, think about the relationship between for loops and list comprehensions. What are the advantages of one versus what are the advantages of another? And if you can, okay, if you have time, create a function which encapsulates all of that, where all you need to do is put in a full directory name and it'll do all of those things on the directory as a function. So that is what you will be working on for the next 10 minutes.
All right, opening the rooms. People that are hopping out of their rooms, do you need help going back to a room? Oh yeah, if you're the only one in a room, you should be able to self-assign yourself to another room, but I could also just send you to one. Thanks for letting me know though. Let me know if you're having trouble getting to the room you want to be in, and I can send you there.
All right, welcome back, welcome back. You know, people are gonna be filtering in for the next 60 seconds. Try to remember that. Ooh, but our time is getting short here. All right, welcome back, people. See, take a look at those. Okay. All right, people are coming on back. Here we go, the breakout room. All right, 6:15 seconds, and then we'll have everybody on back. All right, let me go ahead and share my screen because I really have trouble with that one. That's it. All right, welcome back, folks. Welcome back. So in the interest of time, I'm just gonna scoot through these kind of quickly. Let's see. So one, I did want to say this function right here is said to like make it called read docs. So it would be better to call that read doc because it's just reading one email. So in general, you do want to be careful about that S versus that C. People will read that read doc and be like, ah, and just read one, or read docs and then read one and be confused. So careful about that. I should have written that as read doc. But let's see, let's take a look then. All right, so how can we read this? Yes, the same way that we did before, essentially. This function is going to be, we're going to pass in something called file path, or it's going to have with open file path for reading F, this email equals F read. All right, we already have this written for us. Let's just change this one to 1 and make sure that things are looking good. All right, it works. I see nothing. Let's read this one. Oh, what's going on? All right, it is ignoring anything that I have to say right now. All right, so I think we're there. Oh, does anybody see why this actually did not print anything? I was gonna scoot on by, but anybody know why they didn't print anything?
No return statement.
Perfect. No return statement. Y'all were just gonna let me just let it be wrong? No one was gonna say anything? All right.
Hey, we made the same mistake in our breakout group. That's why I noticed it.
Perfect. Thank you. Thank you. All right, let's run it. Perfect. Now we feel a little bit better. We get some output. All right, great. We see things are looking kind of good. Good. So now we know that we can read a document. Let's see how we can go and read all of them using a list comprehension. Well, we're going to call this all emails breakout. And what are we going to iterate on? All right, so for FPAC in email list up to 20. And what are we going to do with that? We're going to call our function read doc. Read doc, what are we going to call it on? Yes, this little dummy thing that we have here. FPAC, let's run it. All right, things are looking pretty good. I think we can see, well, maybe let's do one here since we did one before. All right, we see that. Is this the same thing? That's the same thing as that one. And then I think this is the same. Yep, this is the same 19 that we're used to looking at. So we have read in all of the emails, and we have written a function to do so. Awesome, list comprehension. All right, let's look at oh, this is already written here. Exciting. So here, oh no, because we've written everything. So here we have exactly what we had before, right? So that was that list comprehension that we literally just wrote, reading all the documents. This is the email that we had, or this is the list comprehension that we had even that we did together. So now for all the emails that are in that email list, for each one, we're going to process that document. We're going to get this one, and then we're going to use our nice unzipish kind of functionality. We're going to empty out all those elements and then reorganize them into all headers and all bodies. Let's run that one. We see nothing here, and so we'll look at a few of these. So here we're just printing some that are at the end. We're printing some at the end. Here we see, okay, things are looking for one, we feel good because this thing here is a list, or a tuple, sorry, I can make it into a list though. Okay, this thing right here is a tuple, and we can see that we have multiple of this in the single one. So 2 dictionaries. And we see the same thing here where, let's see if I can find that. Nope, can't. But essentially we have, oh no, it is there. This one, I think. And then, yep, comma, and then this one. And we're just printing two of them. So this little short thing here that did what we wanted, which is pretty exciting. Yeah, we're at the end of our time. So I did want to talk a little bit more about APIs, but what I'll do is do this super briefly. And so let's just go to Hugging Face. You can just Google that one. Maybe someone can drop it in the chat once they get it. But when you start using these APIs and your generative AI, as we saw yesterday, they will just generate the code that they're knowledgeable of. And so actually, like your GPTs are a good knowledgeable about Hugging Face and early implementations of OpenAI, so itself. And so these are pages that you'll end up looking at. And you'll look at them even more if you don't get like plugins to be able to browse and things like that. So let's see, usually you have like these get started kind of things to get you acclimated. Always look for the tutorials because they're really helpful in terms of if you need to do something, usually there's something to help you with it. Also, there's really nice just like documentation on Hugging Face about things that you can do. So for example, if you're trying to do some natural language processing, this is a good place to start to understand how you would do that. If you are getting to be a little bit in the advanced region where you need to be, for example, creating your own Hugging Face transformer and want to interface with it with the API, or you need to, I don't know, like use different formats of export for models, then you get in here in the developer guides, as well as these. If you have trouble with performance, these are great sets of instructions to understand what's going on with your model and also how to kind of fix it if you have the right sort of hardware to do so. Lots of different help over here, but let's get to the point. So this thing right here, you'll usually see something that's called API reference. And this is what we were talking about in terms of modules. It's not always technically organized directly in terms of the modules, but often it is. And so here, for example, we use pipelines the other day. We can go and look at that documentation. Something I love about Hugging Face, again, is even in their API, they have a lot of just great examples. So you want to try to run something, here it goes. Also, you can, once you get to the actual API part, here, let's get there. So here, so we don't need to get all the way down here, but here you have the different kinds of pipelines that you can use, for example, and you can look at the definitions of them. Even beyond that, oh, also, by the way, you see audio, computer vision, NLP, okay, exciting. Let's look at this one, for example. So recall that we had a class that we defined. Oh my gosh, class, oh my God, there it goes. All right, we had some class that we defined. This is the contract, again, which you need to fulfill to be able to talk with this or be able to utilize this class well. But also do remember how we implemented that call functionality. Remember, so when we call the name of the object of a certain kind of class, we could put in directly the text. These are the other elements that you can put into it. So always look for the call. That is like the actual usage of the model most of the time. Let's see, what else can I tell you super quickly? I think that's going to be like about it. If you need to develop more things about transformers or you're trying to pick out models, it's always great to go to this models page. You can look at the different myriad models that they already have available that you can either fine tune or just use directly. And you can select the tasks based on, what task you're looking for. So whether it be audio, tabular, somebody was talking about tabular the other day, but there's also like a table question answering, wherever that is. I think it's an NLP for that person. Anyways, and so these are a lot of the options that you can use and as well for fine tuning any of these given models. All right, you guys made it through the whole week with me. I'm known to fire hose people and just you're trying to take a sip and I'm just like, here it is. But thank you for hanging around there, hanging in there with us. We will see you on Tuesday. Is that what we read? We'll see you on Tuesday where Miranda and Umang will talk about LangChain. It's going to be super exciting. And we'll be sticking around for the next hour for office hours.
Yeah, and I've just sent an email to you all about the special extra session that will be on Monday, where we'll be talking about transformer architectures. Check your email for it. You don't have to attend. We're going to be taking a deep dive into the actual architecture and algorithms that underlie everything that you've been learning. Great. We'll stick around for office hours.
Thanks for coming.
What questions do you have? Very much enjoyed that, Shara. And we'll the AI assistant really changes things.
Mhm.
Joshua, you have a question? Okay.
I was gonna keep working through the notebook that you didn't quite get to finish. But I can't quite tell from the comments what we're supposed to do. So I imported the pipeline. Were you intending to do like some sort of a text classification task, or you said create a pipeline, but create a pipeline to what? What did you want us to do there?
Yeah, text classification. Yep.
Okay.
Or maybe it will be in the solutions.
Oh, okay, you're right. All right.
I'm thinking that one thing we might want to do, and we might want to do this for next week also, and I can work on this, is come up with some prompts for self-evaluation, for self-quizzing on LangChain.
I like that. That's a good
You know,
one.
and Jesse, I really appreciate you putting in there, you know, the prompts for suggesting the prompts for people to go and figure out for themselves. I think that's terrific.
Yeah, I mean, I think I'm coming across as really, really smart in this, because what I'm doing is I'm taking the question, I'm putting it into GPT, and then I'm typing the answer.
So the early answer is like, man, and then it was like, wait a minute.
Like I actually didn't know the difference between print and display. I was like, what is that? And I typed it over here. It's like, oh, okay, that makes sense. And then I typed an answer in the chat.
So, and y'all break in, because we're just waiting for questions that you all have. So if you have questions, break right in, because otherwise we'll use this time to sort of talk and think, and we won't stop. So break in. It seems like maybe a good approach for the AI assisted coding for new programmers is to start high with the capabilities, right? And then sort of say, well, now let's learn about exactly what it was doing. You know, now we have now let's understand exactly what it's doing, until you get into the programming. And then for the advanced folks, you know, maybe the place to start is the stuff that they never got to, like the tests, and the fact that even if they did tests, the errors that you get out of AI assisted coding are very different from the errors that you make when you yourself are coding or when a human is coding.
I think it's also in both cases also, though, I think we're going to want to make sure that people are in the habit of taking errors or taking questions and immediately throwing them into a GPT prompt,
Yes.
right?
Right.
I don't think it'll take very long, but early on, we're going to make sure we're doing that just so that becomes a habit instead of, because I think what's going to start off first is like, I just got this error and I'm stuck, and I like raise my hand.
Raise my hands, right? Exactly. That's it.
Right. Whereas if instead, and I think it could be, I'm imagining, I actually wrote a note to myself, we could do some of this almost via live coding. I'm imagining it's more in a classroom rather than on a webinar. But like I could do the thing where I've got, the code on one side and the GPT prompt right next to it. And I'm coding, oh, look, here's an error. And I copy and I paste it and I run it. It's like, oh, look, here's the answer. And then I go back over here and I fix it.
Yeah. Yep.
And for instance, one thing I did while you were coding, Shiro, is I actually went back to the for loop where we were looping through reading the files and breaking them out into headers and bodies. And when we were doing the list comprehension later, I just took that code, pasted it into Poe and said, can you rewrite this as a list comprehension? And it was great, actually. Because I suck at list comprehensions, but I know how to write loops, right? So I'm probably going to do that a lot, actually. It's like, hey, I think a list comprehension would be better here. I'll write it as a loop and then say, rewrite this for me as a list comprehension. Boom. So even just little things like that, I mean, that's probably the way to code list comprehensions from now on, because actually trying to think through how to write it as a list comprehension always hurts my brain.
And like for the advanced coders, they may very well not know list comprehensions because that's more of a.
It's very Pythonic, right?
It's very Pythonic, and it's very and it's used a lot more in like deep learning and other things where you're processing data, and you may or may not, even if you're a really good Python programmer, you may never have run across it. So in that case, saying, hey, we're just going to see this as a list comprehension, boom. It's like they can immediately see where the elements map to by looking at it side by side.
So I also wanted to ask you guys about the test cases, right? So would you normally, like as I'm thinking about AI assisted coding, would you still want to write the test cases first? Like I noticed you kind of went through the code, but like, okay, yeah. So like there's a difference between how we teach it and how we would use it in real life. Because there was part of me that it's like, well, as you were going through it, it's like, well, we're writing test cases for a function that we already basically know works, and we expect all these things to work. Now, obviously, you found a few things that didn't quite work, especially with the key thing in the dictionary. But that was an edge case, right? That was where, a header didn't exist. Now, maybe that's a good edge case to catch.
But I mean, actually, that code came out of GPT, ChatGPT.
Right.
And so it was already wrong when it came out. So with the list at the end, like that was foundational.
Yeah.
So I think
right.
but I mean, that's just like a structural kind of thing. But I think so I'll give an example. I was writing R code for something weird. And so it gave me code that ran great, but it wasn't doing the operation, like the data processing operations that I needed it to do. And so I had to like map it out to make sure that it was correct. But if I would have started with a test that said this should be this, then I mean, I could have caught it like right away. But I was just like looking at it, like I read the code and I was like, oh, that's doesn't even look right. But that's because like I learned R. But otherwise, it would have been better for me to write the test of how it should actually work and then just catch the wrongness.
And I think that's going to be a good discipline to get into also in general for coding, because it forces you to think through ahead of time. What am I trying to accomplish? Like, what do my inputs look like? What do my outputs look like? Almost even like drawing it on a whiteboard, right? And like input output diagrams with a box in the middle. And it's like, all right, now I need a function that does this. I can describe that to ChatGPT and it generates it for me. I run it through these test cases. Oh, it's failing. What is it not doing right? Because I think it's too easy sometimes. I mean, I know I do this, is you generate code and it starts generating something. It's like, oh yeah, that's about right. And you keep going. And then later you realize that's not actually quite what I wanted. And then you end up having to go back and change some things because you didn't think clearly and precisely enough about exactly what you want the function to do.
Yeah.
I think maybe real computer programmers are better at that than I am, but I kind of hack things out. And so I make that mistake a lot.
Well, and Omar, I love how you in the chat you actually looked at it to see what to see what was coming out with. If we teach testing first, they will do that forevermore. For the new programmers, for the other programmers, for the more skilled programmers, it'll get them to at least think about it.
But it's like, there's a difference in, and we need to think through this, I think, right? There's a difference between how do we teach them how to use AI to code in that very first class.
Yeah.
Versus ongoing, how do you use this class by class by class as you're going through all your different classes? Because like, do you think it's going to work in that very first class if one of the first things we start talking about is test cases? Is that what you're saying? Do you think we do that?
I think conceptually we can set it up. And so you have to think, well, think through what you want to have happen.
Okay.
And how do you know that it would be, all right, so we're going to, so conceptually you can say, well, we're going to do this thing. This is how we want it to look in our minds. We want it to look like this.
Right.
So we did this. And if you sort of keep on doing that, you say, wouldn't it be nice if you just could you don't have to, write that first. And so you can check to see if it's doing what you thought that it would be doing. And then it's a natural part of, what do you think, Shara?
Yeah, I mean, also I have noticed something that's really good about the generative AI is it's the better that you describe it in terms of code. Like you
Right.
describe with your words, the better and closer it is to what you actually
Exactly.
want. And I think that is something that is powerful, because when you start writing the prompt in a very vague way, then you get something big, and it doesn't actually, most of the time it doesn't actually do what you want it to do. But if you
No.
spell it out, it's going to do a great job. Or it's going to do a job that is better than the original, especially with GPT-4. It's like, God.
And
But
it's
yeah,
harder,
that makes sense.
and it's hard to iterate when it comes up with code because once you see that block of code, and if it's not doing exactly what you wanted to do in the beginning, because you haven't described it well, I think it's really hard to sort of pull yourself out. So if it's in the neighborhood first.
Yeah, I usually try to get it in the neighborhood first and really close, and then but see, that's the thing. I kind of look at it, I'm like, hey, could you do this or this, or I just do it. And so I don't know. I think there's something to be said about the true fundamentals, and experience with those fundamentals. But I still wonder about the assessment part, how to manage that as well. I'm not sure.
The assessment part? Oh, the assessment part of the tests.
Or no, of just teaching any fundamental concepts of Python, because it would be easy to put it into your generative AI.
I think we absolutely would be able to come up with assessment for it. And because really, but especially for data science, because what we want them able to do is to solve problems, right? So we give them problems to solve right off the bat. It's useful with good tests. And that's what we look for. We'll need to think about it a little bit, but we simply never again, we never again can give simple assessments because we're not really interested.
Sorry, I cut you off. Go ahead.
Oh, no, I was just going to say, we're not interested in them, demonstrating that they know they for loop, right? We're interested in they got it. Oh, go ahead.
I guess what I was getting at is a little bit of what Shiro just said, because I think this is correct, that having fundamental knowledge of how programming works and how Python works is going to enable you to write better prompts, right? Because you know more clearly what you're asking for. I knew how to put the prompt in to say, here is a for loop, please use this code and to generate a list comprehension for me, right? I knew that would be something that would work and probably give me a pretty good result. A beginner programmer, if you give them the saying hey, you need to write a list comprehension, maybe they wouldn't think of that, right? And so I think I'm thinking about assessment in two different ways. One, I definitely agree with you that it's almost like it needs to be project-based. We throw a project at them, and then we almost assess the outcome. Did you successfully do this analysis and create the code to do whatever you needed to do at the end, right? Because it's really, can you use code effectively to perform data science tasks, right? That's kind of one learning objective in a sense. But then another thing I think we can do is basically ask them to turn in the transcript of whatever they see, and then figure out a way to assess that, because what we're going to be assessing is their prompts, basically, right? We want to collect their prompts and see how were they prompting the engine, how are they asking the questions to get to get to the final answer. And I think we probably can figure out a way, a rubric type thing, to assess the quality of the prompts. How are they asking GPT for help, and use that to sort of assess how well are they comprehending and understanding what's going on.
Yeah,
Uh,
the prompt,
right?
I mean,
Does that make
it's
sense?
all
Like,
natural
that's tricky.
language, right? It's all
Yeah.
natural language. So in a way, you have like privileged access to how they were thinking about the problem, because that
Right.
is,
Right.
so, we should leverage that. And part of that could be, directly grading. Part of it could be grading against, a policy.
Right.
But we ought to leverage that, because that is how you are thinking. Your prompt is how you were thinking about it.
Well, and like for this summer, that pattern I think is going to be very important, right? The idea of applying some sort of a policy, which to me is the same as a rubric,
Yeah,
against the prompts that a student is putting into the engine
exactly.
to assess them for depth of thinking. That pattern is going to extend beyond even coding.
Yeah.
Right. Like
Yes,
you can use that for a social sciences class or even a sociology
Yes.
class. It can be all text, right? Where you're interacting with a work of fiction, for instance, or a history textbook, right? Like the prompts you put in and the questions that you ask, along with maybe giving them some credit for evolution, right? Maybe early on they're asking, more elementary questions, but later on, do they start asking better and deeper questions, right?
Yes.
But some way of assessing the depth of thought around the questions and the prompts that they're giving to the engine.
Yes.
And then if we do a little thing at the end where it's like, now write me a 10-question quiz, right? Like we could also
Right.
do that.
Exactly.
Right?
Oh, absolutely.
Where we
And-
could say, I mean, that could be something that could even be timed in a sense, right? Where we say like, look, here's a bunch of Python code. We want you to paste these prompts in and to do a quiz. And you need to turn this in 10 minutes or something like that, right? So they need to paste that in with the prompt, have it ask them questions. They have to answer those questions rather quickly and then turn it in. That's gonna assess whether they kind of know it, right? Because you have to know it really fast if it's timed like that.
I mean, I was thinking in terms of assessment. Yeah, so I definitely agree with that. I was also thinking in terms of like foundational. I know I'm on the foundational part. But I was thinking that maybe there's a way to do that as well, where you have some, I don't know, so like today, where I had that first example of the code that we had already written. The thing is, like, there is a scenario where I have that code and I could copy and paste it, but the class can't. And so now at that point, there is no pasting things into ChatGPT to ask about that code. It's, you have to, like, either you have to just ask it kind of blankly, or you have to know it. And so like I could ask easily about certain elements, or what do you think this code does if they cannot. So that is like foundational understanding and a way to assess it without even the ChatGPT or generative AI really being in the picture.
Yeah, so what you're saying is like I could have either on a Zoom call or on a screen up front, I could display some code where they have no ability to copy paste it, and then separately run like a poll or a question, like to get everybody's like,
Yes.
what is this
exactly?
like
Exactly.
that? Yeah, like
And how would you improve it? How would you, right, exactly, what's missing,
right, like that works really well for like formative assessments, right? Where you're like
Formative.
checking understanding and you're like in an actual class period as a part of the instruction, right? Like that's definitely useful in that scenario.
And for others, I think it would be possible to give short, even for performative assessments, you could give many short where it's faster and easier for you to simply respond to it and say, rather than running, a query each time. So you can, you want to do multiple choice, sure. Do 100 multiple choice questions. Are you really going to do 100 queries? But you can just do, if you know it, you can boom, 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 boom.
Well, and also, I mean, since even the paid version of GPT limits you to something like 30 queries every 3 hours, right? If you give them a 90-minute test and it's got 100 questions on it, like they're gonna run, they better be very careful if they're gonna try to put that into GPT. A, they'll be fast, and B, they only have 30 shots.
And even if you do, use, so that the things that won't work anymore are the, blocks of programming, it can have to be the briefer. It's going to have to be where you could actually, gotcha questions are just not the way to go anymore. Gotcha coding questions, right? It's just like, you're going to be able to put those into ChatGPT. You're going to be able to get those figured out. But the ones where you have to think about, and even just by, even if you did do ChatGPT, you'd be learning about what it is because you'd be reading it.
Right.
So
That's why in a way, I'm less worried about formative assessment. I feel like we've got we've got some really great ways to do lots and lots of really good formative assessment, right?
I think absolutely, both in class and also just giving prompts that are dead useful.
I think what I'm worried about is, so there are things that so I guess maybe the question is, like where do we expect the generative AI to be like in August? So if you would expect for it to be like very close to perfect, then I think that maybe, I mean, this is fine. But my issue is that, like, so for example, Hugging Face just came out with agents, right? So this is very new. ChatGPT would not know about it. GPT-4 doesn't know about it. The only one that we can really use easily is Bing, right? And so I prompted it a bunch to write me code that would create an agent, and it just couldn't do it flatly. Like it got some parts, but then it couldn't actually do any of the rest of it. So that is a scenario where somebody is going to have to know something. You got to know something. The prompt is not going to get you there. And so the less you know, the longer it's going to take you to do that thing, which would, like, if you're used to looking at APIs, it's going to take you like 10 minutes. And so
I mean, I'm operating, things are moving fast enough that I'm operating under the assumption that it's going to catch up very quickly, right? So the idea of, oh, I'm going to try to assess based on something GPT doesn't know. Oh yeah.
Jesse, you're breaking up, at least for me.
Yeah, me too. You're breaking up a little bit. I don't know. Oh, now you're muted.
Oh, you're totally. Yeah. And now you're frozen.
Oh no.
Oh no, poor Jesse.
Kind of.
Yep. Now you're coming in bits and pieces, dribs and drabs.
In terms of motion, it looks like you're back.
Yeah.
In terms of motion, it looks like you're back.
Am I back?
I think you're back. I think you're back. So
I mean, I'm just at the office. I mean, you can see, like, it's this Vanderbilt's Wi-Fi, baby.
that's wild.
Yeah.
So, you know, Shara, I'm thinking that you still get to the same place where you have that deep knowledge, but it's not, we don't get there in the same way.
I think it depends on the student. It depends how the students like take it. Because if it is the case that you have to, I mean, it could be the case that you prompt something and then you get an answer back. And then like you might do some more prompting to get you to the right place, but you've never read pretty much anything that ChatGPT says. I almost never read what it has to say. Or GPT-4. I just look at the code and I'm like, ah, looks right. And then I like move on. So if the students are like in this sort of hurry or they need to like complete things and it's like, then there is a chance that they could learn little because they would have never read the things that ChatGPT ever said to it.
Okay. Then can we introduce something where they do? So for example, what about
Right. And then I like
so for example, what about teaching the model? What about teaching the model? I'm going to mute you for a little bit, Jesse. So we're getting feedback, interesting feedback from you. So what about, you know, a regular recurring is teaching the model and then assessing how well you've taught it. Teach the model how for loops work.
Interesting.
And then have the model assess how well it understands.
I like that. That sounds good. I think that could be great.
And we just make it small, you know, but a regular part. Or, okay, now you're explaining this, now you're explaining this. And so it you know, it's necessary to have an understanding.
No, I think that sounds great. I think that's a great way to set. Yeah.
Okay.
Is it working now?
I think so. And for all of you all listening in, a secret among faculty, or at least me, is when I really want to learn something, I'll teach it. That's the best way to learn something really deeply. So, and especially for us, when we have brand new things coming up all the time, we'll say, all right, let's do a workshop on this, because we need to know it really well. And before you walk into that workshop, you really need to know it cold. So it's a way to sort of force the issue, so you have to learn. So the more teaching that the students do, I think the deeper they will learn it. And the problem is
You're
having
talking about like
teaching.
You're talking about like an inversion prompt of sorts, where you say like, I'm a teacher, you're a student, I'm going to teach you how this model works, and then assess you at the end based on what I taught you.
That's right. Assess me.
Sorry, I was gonna say, you know what, that could be a really interesting, like even like graded assignment. Because if they give you like a description of something, you can chain of thought it, right?
Yes.
Then you can ask some like blind question that students actually would never see. And so like that could be at the very end of the prompt, and then you would ask the model to solve that problem given like
Yeah,
only the
exactly. And if it can,
and then
you've done it.
and they can practice all
Well,
the
and oh, I love that idea. Hold on. So this is something we could like use LangChain for, right? Where students could turn in like a transcript of what they have taught. And then I could actually import that into LangChain and say, using this information, solve this problem, and see if they taught well enough to be able to solve the problem.
exactly.
Yeah.
I love that idea.
And we can set it up, and so you can have as many passes at it as you want, or just make it cold, you know.
That would actually be really even interesting for an agent. So maybe we have them describe like maybe certain errors, or we ask them to explain like what to do when you get certain kinds of errors, or I don't know,
Right.
something. And then we, I don't know, with all that, then we like agent it. And if the agent gets the error, then it should be able to solve it given like whatever. So I think it could be a more like sort of complex question addressing a lot. That's interesting. You have to figure it out.
And yeah, I think we can do that. Yep.
So what I was saying back when I was breaking up is that I still think, when I think about learning objectives, I still think there's two main learning objectives in a coding class, right? There's the one, can you actually accomplish useful stuff with code? Right? And this is where I think the project comes in, and a little bit of what Shiro was saying earlier about, well, maybe some students are just copying the code, they paste it in and it works. I mean, there's a sense in which if they can do that successfully, that's good, right? Like that's
they've
helpful.
accomplished part of it. Yeah.
Right? But there is the second part, right? Like she was saying, is actually knowing what the code does, right? And that's actually, in a sense, that's the harder part to assess.
Right.
And that's kind of what we're talking about, right? Is
Yeah.
how do we know that the student really understands what's going on with the code and why this code works?
Yeah.
And that's where, like, I think these, policy prompt patterns, or even, like I said, using LangChain to basically quiz a pseudo trained AI or something like that.
Yeah.
Like we were just talking about, or something like that. To me, that's the way where we can sort of assess their thinking based on the prompts they're giving it, and based on kind of the teaching or the instruction, right? I like that a lot, because that's basically saying like, look, we want you to, use your knowledge to teach this student, right?
Yes.
How this concept works. And then we can basically take whatever it is they put in that prompt and assess it in some way, either with LangChain or some sort of policy prompt or something like that.
Yep.
And then I guess the other part that we need then is we need output formatters, so that if they're generating something in these chatbots, they've got some sort of prompt they put at the end that outputs it into like JSON or something that's standardized, that we can then easily use. Because I'm always thinking about scale, right? Like, what if I'm teaching a class with 100 students in it? How am I going to do this, right? So I need things to be easily standardized, where every student's turning in a document that's formatted exactly the same.
And if the assignment is done with LangChain, that's much simpler to do. If you're doing raw chat, it's a little bit more challenging, but you can get it pretty close. It sometimes has ill-formatted JSON, but then there also might be plugins as well. That's going to be something that we're going to have to explore. We'll have to come up with a robust non-complex way of,
Right.
yeah,
Right, because the thing is the way it can't rely on students knowing LangChain, right? That's going to work for some of our
Oh.
students, but like I'm thinking broadly, like I'm thinking how
oh, yeah,
how's the
no,
business.
I'm thinking if the assignment itself is in LangChain, right? And they're interacting with something which is LangChain, then we have full control over how the export looks, right? If they're interacting with the ChatGPT window or some window, then it's going to be reliant on the prompt. That prompt will have to produce something which is robust. It can't be really, complex, structured JSON. It's got to be simple enough so the model can almost always get it right.
Yeah. It really is that hard? Like it seems to me like there should be a pretty easy way to at least export a chat conversation, just saying like,
Yeah,
user AI response, user AI response, like, and then each one has like a
Yeah.
timestamp of when it was, who wrote it, and what the text was, right?
depending on the interface, yeah, you can do that. And that's sort of an extra step. It's not prompt driven. It is actually going to an interface. So Poe has that. OpenAI chats have that. Bar probably does. Bing just got it. So it's going to vary depending on which one they want. So we'll just need to be more prescriptive about where and how. But we
Right,
can,
like I said, I'm trying to consistently think about like how would this work at the business school, right? So if we're talking about LangChain, does that mean I need to create like my own Streamlit website that students are going to that's running LangChain in the back end? Because business school students are not going to be running LangChain in a Jupyter notebook.
No. Yeah, no, this would be right, something that would be hosted someplace. You could actually, Shara, we have a really nice way of doing, clean looking notebooks. So you could do it with notebooks, or you could do it with a, with a Gradio app or something like that. Keep in mind, we're going to be developing some of this stuff over the summer. So we could create like a standard, I think we really ought to create like a standard quiz where the instructor puts, a paper in a particular place, and then you have a Gradio app that gives the quiz and collects the information and then ships it off where it needs to go.
And also do remember that we have that Vanderbilt has the AWS like back end behind VUNet ID. So if you're talking about like work that is relating student like name or descriptor to like the work that they did or like a grade, you can like create an app on AWS and it's behind VUNet ID. So like everybody can get to it. Everybody can see, not everybody. I mean, it's more secure than like a stream.
Do they have an easy way of getting to single sign-on? Ooh, see, that's
But you have to be like, you have to be pulse secured. Like you have to be on Pulse Secure.
on Pulse. Okay.
If you're off campus, and then I think you have to VUNet ID into it.
And then if you can get access to that, then that would be a great, way. This person definitely signed in with their password to take this quiz.
Yeah, we need to be careful with that though, right? Because we're going to quickly start developing like our own LMS, right? Like,
yeah, no, it's true. It's true. I mean,
right, we're talking about building a platform that any professor at Vanderbilt could use to host a quiz. We've just become Blackboard.
And then true. And then we also become the Blackboard support.
I know that's precisely what I mean, which is why I want to be careful with what we're talking about here.
Yeah, how about how far we go? Good.
Yeah, how far are we going to go with this, right? Like, that's why I like the idea of if there's a way to kind of distribute everything and like, you can tell students, maybe you have to limit what they use, right? Like you can only use Poe or OpenAI because we know they're reliable, but you need to go get your own subscription. And here's the prompt, paste in these prompts, interact in this way, and then run this prompt at the end to capture all the output and then upload that to Brightspace. And then I, the professor, can download all the Brightspace stuff. And maybe I know how to use a Jupyter app, Jupyter notebook, because I can use LangChain because I'm the professor and I'm trained on that.
Yeah.
And then I can just read in all those assignments that the students
That's right.
uploaded, and I can apply some policy or some rubric or whatever. Like that's the workflow I was kind of thinking of.
Sure. Yeah.
So that we're not in like the Blackboard support business, because I don't think we want to do that. I want to be very careful with that. Right?
We could do that for our class, if we want to.
Yeah, sure, of course.
Yeah, but yeah, I agree.
I mean, and honestly, Blackboard or whomever should be building this stuff, right? Like they're probably not
It's gonna
that
be
far
a
away
hot
from.
second. It's gonna be, because it's moving so fast. It is gonna be difficult for people to, because, you know, we're trying to figure out how to get, you know, a university license, you know, for the, you know, university account for the API keys for OpenAI. They have 300 employees. OpenAI does. And they're
Right.
just figuring out how to scale up like this. So. All right. Any questions from folks here? We've been talking
From
a
the
lot.
They're all just lurking, trying to figure out what tests are going to look like next year.
Is it going to be on the test? Yeah. I mean, and I hope that the lesson is, I mean, or I hope that the message is, these are going to be good assessments. I mean, I would love to be assessed by how well I could, you know, teach a model to understand something or to actually do something. Because I've never been a fan of gotcha assignments, which are often sort of the easiest and most highly discriminative, you know, but not terrifically well aligned with whether you're able to do the things you need to do. All right, folks. I'm going to hop off. Sharo, wonderful job. Thank you very much.
My pleasure, always. We know I love talking about coding too much.
Oh yeah, oh no. And then Miranda and Umang, I don't know if Umang is here right now. So you have until Tuesday now to pull your stuff together. So as you're doing it, let me, you know, let us know, like if you want me to do an introduction, if you know, think about what you want.
Okay, yeah, I think we're good. Like I said, I put the collab notebook in our Slack channel. I may need to paste it again because it's probably gotten lost by now, but
Exactly. Yes, exactly. All right. Okay, I'm gonna hop off and take care of a couple of things.
Mm. So I think something interesting that Will Doyle once said is that it's interesting to think about courses in terms of like anti-learning objectives. So if they like come out of the class not being able to know certain things, like what is the extent of the things that they should not, like what is it that we're finding? So if they can't write a for loop just like with their hand, or they can't write like if statement by hand, like they don't have the syntax down, is that fine?
I think so, because I mean, like I mean, I think about it myself in terms, I mean, I guess it depends a little bit maybe on what your ultimate objectives are, right? Someone who is writing code all day, every day, I don't know, they'll probably get it eventually just because of the sheer amount of code you're writing. But like I think about my own life, like I'm kind of a advanced beginner / early intermediate on like 10 or 12 different programming languages, because I have a tendency to kind of pick them up and mess around with them for a little while for a specific task. Like I remember 15 years ago teaching myself Perl because I was trying to do text processing, right? And I know none of that now, right? I could not understand Perl if you paid me to, like millions of dollars without a lot of help. But, you know, if you give me enough time and a book and some example code, I could probably write a decent Perl script if you give me a couple of days, right? And so like, it's really more to me than the main things, as I'm thinking about the learning objectives, particularly around coding, it's, you know, are you able to do useful things, right? Can you actually get your code to work to deliver a valuable product at the end, do some sort of data analysis, generate a visualization, fit a machine learning model, et cetera, right? Can you accomplish tasks, right? Which means you do need it to run, right? You need the syntax to be correct because it needs to run, but that doesn't mean you need to have it memorized, right? If you know that you can take this and throw it into GPT and say, hey, I'm getting this error. What's the fix? And it says, here's the fix. And then you paste it back and then it runs. I think I'm okay with that, right? Like, and maybe you do that enough, eventually you're going to pick it up, but I don't think you need to like have that memorized like at the end of the class.
Okay.
But the tricky part is part 2 of that. So part 1 is getting stuff done, right? Part 2 of that is, do you understand conceptually what's going on? And to me, that is entirely independent of syntax, right? That you can apply to Python, you can apply it to R, maybe not literally any programming language, but a lot of programming languages. Like, do you understand the basics of iteration, if-then statements, different data structures, and what's going on with data structures? And
So then we don't think syntax is important, or no, that's the way poorly phrased. We don't think that they should be able to like write literally the syntax of Python to achieve some certain thing, but they should be able to identify and describe the blocks, the foundational blocks of like what an if-else statement does, what does a
Right.
for. Okay, so that's okay. And so then are we okay then? Do you think that they should be able to describe how those come together to like do the purpose? So let's say that ChatGPT outputs them something and then they have like the if statement for blah, blah, blah. You think they should be able to write out exactly what it does with no generative AI help? Not like the numbers, but just generally, like what does this code do? Like what would you expect it to do? And not something overly complex, but just something not standard, but like maybe standard a little bit. No, something standard.
yeah, so the answer is yes, but I think that the devil's going to be in the details there, right? Because I mean, I even saw it today as you were teaching it when you're asking questions and people are responding in the chat, right? That people can respond to the same question in very different ways, right? When you say, what is this code doing, right?
Mhm.
There is a very elementary response to that question for virtually any line of code.
Mhm.
And there is also a very deep, knowledgeable response for almost any line of code,
Mhm.
right? And so I think the answer to that question is yes. I think students do need to basically know what code is doing. But assessing kind of what level do they need to understand it is tricky, right? Like, because I mean, this is where like more is better, but like I don't know how to draw that line and say they need to understand at least this much, right? Yeah, I'm not sure.
Mhm.
And this is getting back to the idea of like, I mean, I can say things like we need to capture their, GPT transcripts and assess their prompts for depth of thinking. Like, that's a nice thing to say, but what exactly does that mean? what literally what rubric are we going to use to say, oh, this was really like this depth of thinking represents A level work, this depth of thinking represents B level work, like that's really what we're talking about right now, basically, right? I'm not sure.
Maybe there's a way, I mean, maybe there's a way to kind of address it. I don't know. Maybe it's going to come down to the code that we give them. Maybe it's because oh, I'm getting some random feedback, but let me think. Maybe we just have very identifiable blocks of code which do something in particular. Maybe code that they have seen something similar to, but not exactly that or something. I don't know. But I do think they should be able to like have some intuition around what code is doing. So if something has like a if or if like so an internal if statement, like you remember the if body flag or something, like maybe not that granular, but that if statement above it or something like that. I don't know. Just generally, what is this code trying to accomplish, and how do these blocks contribute to the final result?
Yeah, I think so.
So
I mean, and
then,
getting back to your original question about syntax, like they're gonna have to know some syntax because you're gonna have to know that, indenting under a for statement means that's within the for statement, whereas when it's not indented, it's not anymore. Like you're gonna have to know that to even be able to interpret the code, right?
exactly.
So they're gonna get some syntax along the way. So that even that question is murky, right? It's not literally like we don't really care about syntax because they're gonna need to know some of it.
I mean, I think it's just that they don't have to write it like by hand. Because I remember
Right.
we had to use that. We had the handwritten tests. So we had to write the syntax like perfectly.
Hated those.
Yeah.
Uh,
That's not
Those,
something
those
that,
are like those are the bane of my existence, right? Because I always make little mistakes, forget parentheses, forget brackets, whatever. That stuff drives me nuts. Maybe that's my own personal story of why I'm saying I don't want to test students on that.
I think it makes sense. And then also generally with even like the basic code editors, they kind of help you with it anyways. So,
They do.
so then are we okay with them? Is it acceptable for them to, so if some new release of some software or some API comes out, are we fine with them not being able to integrate that code into their code base without a generative AI having it in, like having access to it?
That's a really great question. Because I want to say no to that. I mean, like the students should, I mean, I would like them to be able to read some API documentation and some basic examples, tutorials that you'd see like with a new package and do something with it, even if the generative AI is not on it yet. Otherwise, I feel like we're handicapping them, right? Like they can only use something once it's gotten mature enough that the generative AI works.
Exactly. But then there is the Bing, like that and like the web plugin. I have to experiment with that. But if that works really well, then maybe it's set. But sometimes the way they develop like documentation and source code, it's not even so maybe that's like maybe the piece. Like maybe the assessment can also be applied to, I don't know, like because we can like easily make up an API and then have them like, use it, and then nothing would have any knowledge of it because we just made it up. So
That's true. But also, yeah. That'll test some things, right? I mean, that's going to definitely test their knowledge of being able to like use functions and understand arguments and being able to put the right arguments in there because the generative AI won't do it for them. That's probably a useful test. I don't know if that's like one of our premier learning objectives, but that's probably it. Maybe that's a chunk of it, right?
So maybe another question is, are we okay with if they, let's say that they generate some code, it runs, it does the things that it's supposed to do, but it has additional elements in it which are useless and they serve no purpose other than to make the code longer. And the students don't take those out.
Right, presumably because they don't know, right? They don't know any better. Like they don't really know what that does and it's just in there. I think that's probably something, I don't know that that's fatal, but I think that's probably something that would be like a deduction, right? Because to me, that's showing that you don't know what code does, right?
Okay, I like that. I like that. That makes sense.
If you've got a block of code in there that does nothing, right? And you're leaving it in there because you're afraid that if you take it out, something bad's gonna happen because you don't entirely know what's going on. Right? Like that shows some lack of knowledge. Like I'm not sure they like fail the class because of that, but that's probably like B level or maybe even C level work, depending on how egregious it is.
Okay. And then what if they use unnecessary arguments to like functions or classes, which, so let me go back to that last one. So the thing about the last one is if you include like some really like, there are some things that you can include your code that are actually like vulnerabilities. They can come to a point of vulnerabilities, or they could come to a point like if it's a big bunch of code, then it increases like this chance of you like overwriting this variable because they're just variables in there. And so then your code can go wrong just because of the fact that you named the variable something like standard and some other part of your code actually used it. So I think it's like, it's not like a huge like failure deal, but it is something to think about.
Yeah.
Okay, I think this helps me get a better sense of maybe what, because yeah, I like the anti-learning objectives too. They help me see like what exactly the extent of our what we what we choose to impart. No, I think that's really helpful.
Yeah, it's like using assert statements for your class design.
Exactly. Exactly. No, really.
Well, no, I mean, the thing is, I mean, when I'm designing a class, I think about it like software. Like I think about it like, alpha versions, beta versions, right? Like, it's usually not till year 3 that I feel like it's ready for release.
Totally.
I try not to tell my students that, but like if you got the alpha version of my class, you're my alpha testers. Sorry.
It's true though. That is how it goes. The course development. Yeah. All right. I think that gives me a good, gives me a solid. Now it's just a question of how to assess, or at least homework or something. But I think we've come up with some pretty good ideas.
Yeah. Well, that's why like I think a lot about like learning objectives, what are overall objectives, and then how do I assess them? I mean, that's literally like I'm thinking about this in terms of like what are the unit tests I'm going to put on my class, right? Like what do I want them to know, and how am I going to know that they know that at the end? And then once I've kind of got those nailed down, then you start going from there and kind of breaking that down into smaller pieces along the way of what other kind of assessments do we need to have along the way. And then if those are my goals, how then do I design the day-to-day classes to make sure that they're set up for success to actually achieve those goals, right? I mean, like I said, that's why I think about my class like software.
I love that. That's actually really interesting. Somebody should write a book on that. We should write a book on that. Course design is software.
Well, course design is software. That might be original. I mean, everything I just told you about course design is not original. Like that's, I mean, anybody at the Center for Teaching can tell you that. But the idea of thinking about it as software maybe is original. I don't know. I'll chat write a book for me.
Yeah.
I don't have time to write a book, so I'm gonna have to generate it.
Edit it here and there. Yeah.
Yeah.
All right. I don't know that does anyone have any last burning questions?
Is anybody besides the 3 of us even on this call anymore? I have a feeling they're just like, they're doing something else and everything's muted.
I think Abby's around, and then there's 2 participants.
My
Yeah,
cat has been an
doing
active
other stuff,
participant.
but-
I would like for everyone to see my cat's bow tie.
Wait, let me see. Oh,
You might have to take off the. Oh, I see it. Okay, yeah.
You see it?
I do see it
He's very
now.
dapper today.
he is. He's very clever.
We are taking him camping this weekend.
So, camping bow ties. I don't
Oh no, you're
think
breaking up, Jesse. What are you saying?
good.
I'm sure it's great. Oh man.
I heard camping with the bow tie.
Yeah.
Oh, that is so cute. How do you think he's gonna take it?
Oh, I think he's gonna have a lot of fun. He's really adventurous. So we take him on hikes. He has a backpack. He loves going on adventures. So we really want to take him camping. Oh, Jesse, are you back? You back?
Maybe.
Oh.
I think it might be my
Oh.
Zoom. Nope, I'm not back.
You're sort of back, I think.
Yeah, I think you're back. I think there's a delay maybe.
Great.
So I'll just wait a couple seconds.
Great. I was just saying that I wasn't sure a bow tie and camping go together. He needs like a Patagonia hat and like some hiking, something like that.
Yeah. Yeah. The bow tie, I guess, is because it's a special occasion, but also it's the only collar we have that he doesn't immediately tear off for some reason. So
Okay,
If he's
my
gonna wear a
cat-
bow tie, we need to take him to the opera.
There we go. He said, hello, my name is Anakin. Anakin.
oh hello. Oh my goodness. What is this cat's name?
Anakin?
Anakin?
Yeah, like
Adorable.
Anakin Skywalker, because he's like a little
Adorable.
rat. He's like, whenever he gets like upset, he becomes, he's the women and the children too. That's how he gets.
I hope he hasn't committed genocide.
Right?
You can never be sure with cat.
Exactly. Exactly. Hello, Alan. All right, I think we can, let me see. No, there's no. Yeah, I think we can consider ourselves finished. Maybe take a little 5-minute break before the next thing, and
Yeah.
thanks
I'm gonna head
everybody for hanging
See
out.
ya.
All right. Have a great weekend.